In this example, we're trying to find the values of x and y by using interesting theorems that determine relationships between angles, interior angles. So notice that, first of all, these two line segments are parallel, indicated by the arrowheads here. So we can treat these two crossing lines of these two parallel lines as transversals, right? So this is the first transversal, this is the second transversal. So once we have a transversal that has a relationship or crosses the parallel lines, in this case parallel line segments, we know we can use theorems that determine angle relationships, interior angle relationships. So notice here we can solve for x directly because if these two are parallel and this is a transversal, we know that we can treat these two as consecutive interior angles, right? So 2x degrees plus this 90-degree angle, because this is a right angle, together they're called consecutive interior angles. And we know that consecutive interior angles are supplementary, okay, when these two lines are parallel. So if it's supplementary, it means the sum of the 2x and the 90 is 180. So that means if you subtract 90 from 180 from the sum of these two, you will get the value of this angle. And since we're subtracting 90 from 180, 2x degrees is equal to 90 degrees. Okay? So if we label this as A, for example, angle A, we know that the 2x degrees plus the measure of angle A is equal to 180 degrees, right? Supplementary. Right, supplementary, and again, what is that responsible for? This is from the consecutive interior angle theorem. All right, so this is from the consecutive interior angles theorem. So now we can basically solve for the x using the fact that measure of angle A is 90 degrees, right? Because it's shown as a right angle. All right, so that's 180 degrees. So as a result, you subtract 90. 2x degrees is equal to 90 degrees. So as a result of which the x is equal to 45 degrees, right? So that's the value of x. So notice you can also find the value of the y in two ways. You can use the formula for the total, for the sum of the interior angles in a quadrilateral, or you can just simply use, again, angle relationships, because you can use this transversal, and you know that these two represent another set or another pair of consecutive interior angles, right? So we know that 3y plus 6y degrees is equal to 180 degrees, right? Because these two are, again, consecutive interior angles. This is the second pair. Okay? So now we know we can combine like terms. We know that 6y plus 3y is equal to 9y. 9y degrees is equal to 180 degrees. So as a result of which, if you divide both sides by 9, you will get y is equal to how much? Y is equal to 180 divided by 9, right? 180 divided by 9 is going to be 20 degrees. All right, so the value of y is 20. So this is that, and the other part that we've solved for was this. Okay, and once again, you can use the second method to find the value of the y, since you know the value of x and you know that this is 90, right? Because the sum of these four should be 360 degrees, because this polygon has four sides, and the sum of the interior angles for any quadrilateral is equal to 360 degrees. So let's just do that for fun to confirm that it's going to be the same thing. Method 2. So how do we get 360 degrees? Remember, there's a formula. There's a formula that gives you, so let's write that, interior angle sum. So how is that possible? That comes from 180, the formula, times the number of sides minus 2. Okay, so the number of sides What is that going to be? Let's see. The number of sides is going to be 4 because this is a quadrilateral. 4 sides, and the same thing, 4 angles inside. So that's 4 minus 2, so that's 180 times 2, which is 360. So 360 is the total sum. So if you just add 3y plus 6y plus 2x, 2x was what, 90 degrees? Plus the right angle, 90, is equal to 360. Notice that if you subtract two 90s here, so subtracting 180, as a result, you will get something like this. 9y, if you combine like terms, would be equal to 180 degrees. And you're back to where you were, right? 9y degrees is equal to 180. So you see, this method works as well. But the point of this video was to really use the angle theorem relationships and pick the appropriate one for this kind of situation. So I hope this was helpful. Thank you so much for watching. See you in the next video.